Now, let's travel into the digital sphere to explore to what extent that sector is changing the game. We are, after all, living in the midst of the fourth industrial revolution, the digital one, where the technology development happens so fast that we're struggling to keep up. How can digital technology help the energy transition forward? Someone who is well positioned to give us insightful answers to that is Hege Skryseth. She is the CEO of Kongsberg Digital, a provider of software and digital solutions to the maritime and the oil and gas industries. She is ready to answer your questions after her presentation, so please post your comments on Slido, and you can look into the chat and see the correct URL. It's slide.do, and the code is still ET Gamechangers. But first, Hege is inviting us on a virtual journey into the land of digital twins. So just buckle up and get ready to join Hege Skryseth.
Hello everyone, my name is Hege Skryseth. I'm the CEO of Kongsberg Digital. Today I'm going to talk about transformation of the energy industry, one of the most important industries in the world. Kongsberg Digital was established back in 2016. We were set off to contribute and transform two of the leading industries in the world, the maritime industry and also the energy industry overall. So today I'm going to give you an example of a technology that has significant impact and have the power within the technology and the transformational processes around it to transform the energy industry for the years to come. Now we're going to have a look at a demo, but first I just want to take you into the context of the digital twin. So from a technology standpoint, it's really a virtual representation of a physical asset, and it also takes into consideration all of the various processes, the data that's collected across the various sensors, and also physical models to map out everything that's ongoing on an asset. And let's now have a look at Oseberg H at the Norwegian continental shelf. So here we are flying in over the Norwegian continental shelf, and what you soon will be seeing is a full representation of the asset itself. And of course, given that this is an unmanned asset, it's very important to also have a full overview of the surroundings. So everything you see here is in real time, meaning that the sea model is in real time. You will also see surrounding vessels, as we are looking at here now, where we have the AIS data, so that we are able to identify the vessel, what type of vessel, what type of cargo, what's the relation to the platform, etc., which is important not only from logistics standpoint, but also from a security standpoint. And as we now are flying back to the platform again, we can go in and look at all of the various components on board the platform. We can zoom in to different components, and with the use of the physical models, we also have an opportunity to identify if there's any issues that we need to look into. Meaning that we do a comparison in between the simulator and the actual state and the wanted state of the various components. As you can see, we have also connected this to PNIDs, meaning that that's a dynamic connection, meaning any changes on the PNIDs also reflect the asset itself. So any changes or any updates to the PNIDs will also impact directly the virtual model, the digital twin. We can do all types of measures. We could also incorporate CCTV, as you see an example of here. We can train machine learning algorithms based on the physical models and apply those for increased production, etc. So there's a number of capabilities within a twin like this that the operator can take advantage of. If you are focused on the production part, you can also then extrapolate only the visualization that's of interest, and you can go in and look if there's any issues in any of the risers. And you can even use the physical model then to look into the more details on the process to see what to accommodate when it comes to managing the task. So what we see here is really that we have a challenge. We have to infuse some more gas into the riser due to the pressure point in the riser. So this was a short demonstration of the basic functionality in a digital twin, and we will now go on and show you a couple of use cases on how you can use applications on top of the digital twin. And now I'm going to introduce you to a use case on compressors and energy optimizer. So the optimizer is now running, and what we can see here is a simplified schematics of the process model. Behind this we have a fully dynamic process model representing the whole system. It is possible to spin up as many instances of the model as you require. Here we are showing 4 in parallel. These physical models represent the behavior of the system, and we can test different scenarios to see what changes provide the best improvement. So number one, first one is running on the current online conditions. Number two is predicting how it will look into the future. And the number one optimization, looking at how we can reduce seawater, lift pump, power consumption. And number two here is a bit more complex, looking at how set points in the plant can be altered. So I now want you to keep an eye on the total power consumption here and the total gas export, as you can also see visualized in the 2 graphs here. Of course, gas is valuable, so we try to keep the production as high as possible at the same time while lowering the power consumption. And now we're going to look at a different use case that is simultaneous operation and permit to work. Overall, the main cause of all incidents in the oil and gas industry is equipment failure, followed by human error. The majority of these incidents occurred during production operations. With increased visibility and production operations, these incidents can be significantly reduced. Okay, here we can see our digital twin for the Nyhamna gas plant for Shell, the technical service provider of the facility. This is an updated dynamic twin where we can see every detail in 3D for many benefits. Let's say that I'm a worker at the gas plant and want to do some specific type of work on a specific day. How would I know that there are no other conflicting work happening on that day in the same area? In order to do a proper safe job analysis, traditionally this would have been an extensive process. But with our new digital twin application, SimOps, simultaneous operations and permit to work, you can easily, for any given date, quickly visualize what is happening on the plant for that day, as you can see in the top right corner here. This was just a few examples on how the digital twin technology can be applied on an asset and an operation. Analyst firms are projecting that this could save operators 30% on CapEx and up to 50% on OpEx, and also the likelihood of increasing production 10 to 15%. This is also confirmed by large operators where they see this as a very strong technology to actually transform the way they are working. And of course, with an ease of use user interface that we have seen now, it's also an opportunity to ensure that all of the different expert functions are able to work together and work on the same user interface. It also allows non-expert users to get a full overview of what's going on in the different production assets. So hopefully this was of value, and as I mentioned, it was only a sneak peek into some of the functionality a digital twin can offer, and thank you for the attention.
Thank you very much, Hege, for that interesting insight into the digital twins. And now I would like you to come back on camera. There you are. Hello again.
Hello, hello.
So I was wondering, Hege, because now you showed us some examples of how the oil and gas industry are performing better in many ways, both enhancing production, lowering the costs, probably using less energy as well, and you know, increasing their production. But if we're looking into the energy transition and maybe towards a more renewable energy system, how can these technologies, for instance, the digital twins, be used in that sense from the renewable sector?
I think there's many transitions going on at the same time here. So basically, we are transitioning with technology for the brownfields. We are setting up greenfields in a different manner. We are able to significantly reduce emissions when it comes to, of course, the safety of the platforms, but also on energy consumption. And I think this technology could easily be applied also to other energy sources.
Okay. And if I understood you correctly, what you're actually doing in the digital twin is to sort of combine well-known technologies and data. It was like BIM, you had 3D data, you mentioned AIS, etc. So it's all about understanding how to use the technology which is already there. Do you feel that you know, the different actors in the energy sector are good enough in taking this into new uses?
I think there's a lot of curiosity around new technology, but I still think that it's not fully connected to how you transform your organization to adapt to sort of the new opportunities that the technology allows you. Because the technology is there, so it's all about how you use it and how you apply it, and how you also change your work processes to fully accommodate the opportunities.
Precisely. So as you saw with David, our first speaker, we had this expert panel asking questions. Now I'm crossing my fingers because I know that Thomas had some sound issues earlier, but I'm crossing my fingers that he's ready to ask you a question. So Thomas, are you there? Yeah, I can see you there. Can you hear us as well? You're smiling, so you're probably hearing us.
I can hear you.
Perfect. So what would you like to interrogate Hege with?
Yeah, I would actually like to press a little bit further on what you started with, Ruth, because this is extremely fascinating, of course, digital twins and this entire sort of model duplicate world that is emerging across multiple fields. It's used in the sectors you talked about here, but also in other sites. And that can be a really powerful, useful tool for transforming operations, as you said. But on the other hand, the kind of more cynical take on this is that, well, we have huge, powerful actors such as you guys in this situation, in constellations with oil and gas actors in this situations, building even more powerful technologies, more investments, putting more effort into kind of building synergies around essentially a carbon-based economy. And you sort of dodged it by saying that this can easily be applied to other technologies, but that is a bit of a trick answer, because most things can be applied to other sectors, but there's, you know, the proof of the pudding is in the eating. So it's then a matter of which are your companies and your associates' strategies for sort of pushing in that direction in terms of pushing maybe oil and gas into renewable ventures, into sort of making broader transformations, not only within the oil and gas industry, which is important, but more broader in society as such, so that we do not only incrementally move slowly towards not really meeting our climate targets, but radically and game-changingly move in, fundamentally transformative direction as a society. So.
Big question.
I think, as I said in my last answer, is that I think there's many transitions going on at the same time here, and I think the dependency in the world still, when it comes to oil, is going to be there for a while. So the opportunity that this allows for a safe operation and also significant reduce in energy consumption is still going to be there. Then it comes to gas. We have a tendency to say oil and gas in the same sentence, and I think that gas is going to be a dependency in the world for a long time. We also have developed the same technology for grids, and that is really to be able to do the balancing and flexibility within the grid to accommodate the electrification that's happening without having to build a monster mass and all of the other infrastructure part of that. So we are somewhere in both areas, I would say. So it's I think it's important to ensure that the new technology also is accommodating the existing establishments. And I think it's quite easily transferred. And what I said about the grids, it's really the same technology, just applied for grid.
So we'll just have to see then what happens. And I understood, Thomas, that he wanted you to sort of push forward even harder and more actively in that effort to transform this. You heard it. So yeah, you're going to do that. That's good. That's good. Okay. Hege, just a point, and I'm sorry, Thomas, I know that you probably would like to discuss more, but you're going to have the chance to do that later on. One quick question from the audience, Hege. Most of the emissions from the oil and gas industry come from power generation and flaring. How can digital twins help reduce these emissions? Or can they?
What we see is that there's quite high ambitions on the energy consumption part from many operators. And if we look at the Nyhamna that I presented here, if they reduce the energy consumption by 1%, it equals 11,000 households. And that's Norwegian households, meaning we use a lot of heating, etc. during the winter time. So there's many options and opportunities in here, I think.
So we're going to get back to you later on, Hege. Thank you for now, and we'll see you again for the discussion. So people can still ask questions to you and the others.